In the previous part, we briefly discussed about the kinds of near real-time data available from IMD, that is the Indian Meteorological Department, to keep track of the day-to-day evolution of monsoon. Here we shall look more closely into the quality of the data. Specifically, we shall look into how well the ISRO satellite images shown here correspond to the IMD ground station data. We shall compare the ground station data from different agencies and sources in a later part. Here we will look closely at the July 13th event, that is the rainfall associated with this large red blob showing very intense rains in the Maharashtra, Telangana, Chhathisgarh and Madhya Pradesh region. July 13th means the 24-hour period between 12th July 8:30 am to 13th July 8:30 am, because that is the standard used by IMD for reporting daily data. The satellite 24 hours may be slightly different. It seems like they switch from one day to another day sometime around 5:30 am. Probably they are following the UTC, that is the Universal Time Coordinate standard, UTC standard. However, I have not read their documentations and I have just explored the details that are available from the IMD page where this dataset is hosted and from where I downloaded these images, ISRO images. So for the satellite images, July 13th means the time period between July 12th 5:30 am to 13th July 5:30 am. And for IMD, July 13th means as noted earlier, July 13th means the time period between 12th July 8:30 am to 13th July 8:30 am. So there is a mismatch of 6 hours between IMD and ISRO data. Only 18 hours of data between 12th July 8:30 am to 13th July 5:30 am is common. So this is the satellite derived daily rainfall rate. It shows extremely heavy rains of the order of 300 mm in this central Indian region. Let us take a closer look at this region. This region, bounded by this blue curve, is roughly the region showing 300 mm rains in the satellite image. It is like bounded by Chhindwara, Khandwa, Parbhani, Karimnagar, Sukma and Kalahasti. From the high resolution topography data, we can see that this region is like the place where the Western Ghats, the Eastern Ghats and also the Satpura mountain ranges meet. And this low-lying region in blue and pink is the Godavari river basin. So it is expected that such heavy rains in this region will cause flood in the Godavari river. Let us look at the rains recorded by ground stations. These are some of the district average rains for the regions with high rains reported by IMD on July 13th morning. So it corresponds to the rain between 12th July morning to 13th July morning 8:30 am. We see there are only 2 places with more than 200 mm rains in this whole area. Most places recorded 50 to 70 mm. 8 stations had between 100 to 200 mm. Even examining the previous day and next day rain amounts do not indicate there was a large scale 300 millimeter rain in this whole region as indicated by the satellite image. The satellite seems to be capturing persistent deep cloud systems in this region rather than the actual rain amounts. Also, in the in-between regions, and especially on the Chhathisgarh side, the station density seems to be quite less. So most of the rains are located in these between these two blue curves, in these within these two blue curves, maximum intense rains. So the most intense rains seem to be associated with these three topographic features. The region here is associated with the Western Ghats. This region on the right is associated with Eastern Ghats, and this region on top is associated with the Satpura mountain range. In fact, most intense rains were recorded by the IMD ground stations from the northern Telangana region of the Godavari basin associated with Western Ghats. This district, Nirmal, had the highest rain on 13 July. It recorded 230 mm. Peddapalle recorded 204 mm, Jagtial 187 mm, Komaram Bhim 185 mm, and so on. All these places are located near the tributary streams of Godavari. Over the 3 days centered on this 13th July date, between 11th July 8:30 am to 14th July 8:30 am, some of these places in this region had in excess of 300 millimeter rains. These 7 stations marked here, to be precise, they had more than 300 mm all, and 6 more stations around them had between 200 to 300 millimeter during these 3 days. That is, only about a dozen stations recorded above 200 millimeter rains amongst the many dozens of stations in this region. Therefore, large-scale rains around 300 millimeter recorded by the ISRO images cannot be real. Only few stations in this whole region may have had that kind of value, and possibly all of them were associated with some elevated topographic feature. So, a day or two after these rains, large-scale flooding in Telangana were reported from July 15th, 16th onwards. It is reported to have affected more than 65,000 people in 628 villages. And a huge amount of this water was lost into the sea almost immediately after the rains. The flood situation persisted for a few more days due to continued heavy rainfall in that region. Further, in the satellite image, we notice that the Western Ghats portion of Karnataka and the southern part of Maharashtra show pretty heavy rains of the order of 150 mm in the satellite image. And it shows relatively much lower rainfall in the northern side of Western Ghats around Gujarat. But when we look at the IMD ground station data, we see that the Karnataka coast hardly shows any rains above 50 millimeter. Even the Goa rains were only 30 millimeters, so we have not shown it. The largest rain here is about 71 mm, and it is found in Wayanad, pretty far from the Karnataka coast. So the color coding along the coastal Karnataka region seems false. Satellite seems to be overestimating the rains in the central Indian and the coastal Karnataka region on this day. And in the northern Western Ghats, where the satellite images show much lower rains, we find that the ground stations have recorded much higher rains than the Karnataka coast. There are 8 stations which recorded 70 millimeter and above, and one station almost recorded 150 millimeter rain on this day, and the satellite seems to completely miss this rainfall events. Besides the IMD data, in Karnataka region there is another independent agency, the KSNDMC, which maintains its own network of ground stations, and we note that often the numbers reported by these two agencies, IMD and KSNDMC, they do not match. The district average, say rainfall that is reported by them, they do not match. We will make proper comparisons between IMD and KSNDMC data in a future video. For now, we just note the differences on this date in these 4 stations. For Udupi district, KSNDMC measured 64 millimeter and IMD measured only 51.4 mm on this day. For Chikmagaluru, KSNDMC measured 40 mm while IMD measured 52.1 mm. We can also note small differences in the Shivamogga and the Karwar rainfall. If such differences exist within contemporary data sets produced by different agencies, I wonder how can we trust the minute long-term trends, 100-year trends estimated using data from different agencies, measurements derived from different types of instruments, and methods using different types of calculation methods for area averages and so on. Probably just the rounding of errors that might be committed by humans while calculating area or time averages in the olden times may induce some trend in the data. In this context, I just want to mention a mail exchange I had with KSNDMC. I had noticed that the Bangalore range, for the Bangalore range, the two agencies are giving different numbers. Sometimes they differed by quite a number of millimeters, and so I noticed this around June 18th, and I mailed them to ask about it. I got a response from KSNDMC. They said that as per KSNDMC daily report, in the last 24 hours, the entire South Interior region has recorded 7.2 mm, and Bangalore urban recorded 14.1 mm. But as per IMD report, South Interior region has recorded only 4.6 mm. So here KSND is 7.2 mm, IMD is 4.6. And Bangalore urban district recorded 22.3 mm by IMD. And Bangalore urban district rain through KSNDMC is 14.1. So this is 14.1, this is 22.3. Also, IMD is giving an arithmetic average rainfall data, but KSNDMC is calculating rainfall using Thyssen polygon weighted average method. So the two area averaging methods are different. And also KSNDMC has more than 200 rain gauges in stations in Bangalore urban district itself. And IMD has only few rain gauges. Maybe 5, 6 or something. So the discrepancy is common due to density of the rain gauges and method of rainfall calculation. So this is what the KSNDMC response was. So they acknowledge that the differences exist, and this is why, because of the density of the rain gauges and the calculation method, the difference exists. So possibly the KSNDMC data is more reliable in this case. We shall see more comparisons between KSNDMC and IMD in a future video, and also try to estimate the errors caused by dropping a few stations or dropping few days from a certain station while estimating district averages based on multiple ground stations data in that district. So each district will have typically multiple ground station weather stations. So how we calculate the district average using them, and what are the numbers reported by KSNDMC and IMD, we will look closely into that. And also IMD individual station data we can consider and do some experiments with it. So we'll do that in the next part. I'll end this presentation here. Thank you for watching the video. Please share it and subscribe to the channel. Thank you.